Well, hi, good morning. Thanks for joining me here. So the last video ended with me discovering that the metal shield is missing from this radio for the original 6Q7, which would certainly explain why there's all kinds of weird oscillations. And there's a reason why they put a metal shield around a tube like this. But I've replaced it. I've replaced it with a tube that has its internal metal, hardly internal, it's actually kind of external, metal cover on it. So it dawned on me that since this has no metal shield, germane to the tube itself, then the metal shield you put on would have to be grounded to the chassis through some other method. Now, often there's a metal ring down here, and you set the can down, it makes just a contact. There's no such ring around here, so I'm really not sure if there really was a metal shield on here, how that shield was grounded. Maybe there's a wire coming to it, I don't know. So, but the point is, no metal shield inherent with this tube. Metal shield here. This metal shield must be produced onto one of the pins of the tube. Otherwise, what good is it? You have to be able to access the metal of this shield just as you would the metal of the can around this tube. So I figured, okay, one pin in this tube is intended to go to ground, and that same pin in this tube, well, it's just not connected to anything inside. That's pin number 1. I got pretty excited. This will be it. I'll find pin number 1 here. Either they've abused the socket for other purposes on pin 1 and now it's causing big problems, or pin number 1 is just open in the radio. Check that out. Pin number 1 is grounded to the chassis. In fact, let me just show you how they've done this, because now I look at it a little closer. Sometimes you just don't see things until you look, you gotta look first. So let's look at this socket up here at the top. So you can clearly see those solder to the chassis. If you look more closely, you can see that there's no terminal sticking up. Let me point to this so I make sure you know what I'm saying. There's no terminal here. The terminal is here, pushed flat against the chassis. But look, I've seen this in other radios. They're just bent over, but this is not bent over. This is actually underneath this piece here. Same thing here. And then there's a rivet holding this top piece. So this tube socket must have been manufactured with these tangs sticking out here, ready to be soldered to the chassis. So my suspicion is these are made by the radio manufacturer specifically for this radio. So we come down to the one in question. That's the 6Q7 here. Come around. Wind. Radio's not on, by the way. Just double checking after saying that. So we look for pin number 1. Let's see if I can get this on camera. So you can see the bump here. Can I point to it? Where am I? Am I on the wrong tube? Yeah, first I gotta point to the pointer. There we are. Okay, so if you look, there's the key. So that's pin 1 right here. Oops. I'm watching in the camera, in the screen here, so it's difficult. There's pin 1. Look, there's no terminal. In fact, the terminal, you can tell it's soldered down there. Soldered to the chassis. I checked this with my ohmmeter just to be sure there's nothing wrong here. There's nothing wrong. So what that means is this metal shield is almost certainly connected to the chassis the way it's intended to be, even though I've changed it to a different tube here. It also means I don't know what to do next. So before I turned on the cameras here this morning, I spent a great deal of time simply going around all the capacitors I've installed, all the work I've done, verifying each and every capacitor is done properly and in the right location, verifying the connections are good. Just everything I can think of I have gone through and double checked. And as far as I'm concerned, this radio is perfectly correctly wired. That's where my head is on this. So with that in my head, no use looking at how the parts are arranged. What am I left with? when I put that tube in, the radio's behavior changed. It did change. It just didn't come to full goodness. It just stopped short of that. So I think what I should do, first of all, is take stock of the way this radio is operating. So I'm going to turn it on. Turn it on right now. Let's turn it on right now. Let it warm up a bit. Something I've done additionally is I've put this meter here connected, very, very simply connected across the outside terminals of the volume control there. And so that's going to read the AVC voltage, particularly if I turn it on. Some of you have sent me some interesting information, and I've taken a look at it. There's a link to some stuff on the internet I've taken a look at. And other people have struggled with very similar problems in radios with this same 6Q7 tube. Now, of course, I'm searching on the internet, so what am I finding? I'm searching for 6Q7. I'm going to find people talking about it. But this problem with this radio is kind of similar to what some others were talking about. And one of the things they did was, as the radio went in and out of oscillation, they just monitored the AVC voltage to recognize when there was a signal in the IF, which is going to be rectified and going to produce this kind of voltage. So right now we're looking at the AVC voltage minus 2.4, which is right, roughly where it should be. What's going on here? Oh, I don't have it on full power. Let's go full power. Going a fair bit negative. Turn it up. I gotta put a no, I was gonna say I had to put an antenna on it. Let's not. So this is no signal entering the radio. In fact, I can go even further. I can short out the I don't think I've ever done this. Let's short out the antenna. Just before I do it, just a little bit there. Volume is full, so we're getting -4 right now as an AVC voltage. Tune the radio, just watch what happens to the AVC voltage here. It's going up and up and up. Now that's interesting in itself. It's going back. Oop. Wouldn't you think that tone would happen with a variation in this voltage? No. Okay, let's keep going. Let me go back through that. So the audio tone we're hearing is not part of what the detector is detecting. Kind of roll that back. Let me say that a different way. The voltage we're watching here doesn't seem to be influenced by the fact that a tone is coming out of the speaker. Keep going. Okay, so that's one end of the capacitor, tuning capacitor. Just go down. It kind of jumped up there in the middle, did it? Let me just go back. No, I don't think so. Go back down, down, down. Almost at the end now. It's almost suggesting that as you tune the radio, you're just varying something that's going through the IF. The radio's totally quiet now. Why is that, for crying out loud? So I think there's an oscillation in here even as we're standing here. It's not terribly reassuring. Not that the meter, nothing to do with the meter, just the fact that this isn't screaming out of the speaker. The volume's right up. And this is after the volume control anyway, so this is full steam through that tube and through the output tube. Won't worry about the volume level right now. I should have my eyes on that when I did that, because the radio's, just make observations. minus 0.5. What's that? So generally speaking, more sound out the speaker, higher AVC voltage. Not quite true, generally. Generally misspeaking about that. I would expect if I stick my finger on this tube and I get more crap coming out of the speaker, that this voltage would go more negative. That's what I would expect. One of the other things I expect is consistent behavior, but it's definitely not there. Wasn't this 2 volts just a moment ago? Why is it half now? Fool with the volume here. Didn't do anything. Good. Fool with the tone. Oh. I heard a funny whump come out of this radio. It was very subtle. And then this changed. Back with the tone. Tone control shouldn't be doing this. So that's one limit on the tone control. What's the other? How can tone control be affecting the AVC voltage? Is that normal? I wouldn't think so. Here's the tone control. So the tone control is, let's see, hooked to the... So what's going on here is the sound coming out of here goes through the volume control. There's this back, like 4th connection onto the volume control. What I refer to as a back tab. And that's what's hooked up through this rather large 1.5 megohm control. But you can... So if you turn the control here, you placed a ground on the bottom of this. I'm not looking at this right. Why is this connection even here? Oh, it's just another connection to ground, except it goes through this capacitor. Is that right? Is that what they've done? So we just consider this another ground point here. Why'd they do that? So, you know, there is this thing about human hearing where when the volume gets low, if you look at the range of our hearing, like low frequency and high frequencies, so that's the range of our hearing. As the volume goes low, our hearing starts doing this. So at low volumes, if you're listening to music, our ears won't hear the bass and the treble as much, particularly the bass, I believe. So one way to make music sound normal at low levels is to boost these things up to compensate for our droopy ear response. So I think these kinds of thoughts were going on in people's heads back in 1938 when they were making this radio. And so in the modern equipment, often this is referred to as loudness. You have a little loudness switch, so when you're listening at low levels, you flip this loudness switch. It just boosts the bass and treble, compensate gain for your human hearing. So I don't know this to be true, you know. Hey, it's just because I shoot videos. It should be apparent to you by now. I don't know everything under the sun here. So how they utilize this back tab. I mean, there's another problem with volume controls in that they're non-linear. And if you're not careful, all the action happens either right in the first bit, the first 10-20%, or the last 10-20% of the turn of the control. So I've always thought this is a way to compensate for those problems. I mean, it's a sneaky way to sneak some loudness effect into the volume control. And that's what I think is going on. Am I right? Geez, I don't know. So if we assume that this is just another connection to ground, then all that's happening here is as you move the slider up, you're pulling more and more treble out of the signal that's traveling to the output. Okay, back to the thing. Why would it change the ABC voltage? So we have DC here, we have DC all the way through here. The DC is blocked from carrying on over this way. It's not blocked through here. It's not blocked through here, or is it? Carry on. You know what? It's blocked this way and it's blocked up here. So there's no DC flowing through this, and that's very important. Am I drooping here? You don't want DC flowing through these controls, or they're going to always going to sound like that. In fact, that's an indication of a leak in some of these capacitors. Is a volume control, you cannot stop the noise no matter how much you clean it. There's actually some DC going through it. So all that being said, once again, the big question: how does moving this control change the voltage? There should be no. What went through my head was somehow when you change the tone control, it affects the signal that's being detected up here. I can't see it. I cannot see it. This is a two-part tube here. This thing is kind of involved with the triode part, and the ABC in that is involved with the DC part. Can I say that? With the diode part. These could be two separate tubes. And they are in some radios. So look for some kind of misconnection between, what's over here and what's over here. Over here, assuming that turning the tone control really shouldn't do that. I think you can even hear the radio get quieter. That's a lower voltage. Higher voltage, the radio got a touch quieter. So that's what ABC would do. Hey, wait a minute. How come I got 3 there? 2.9 all the way, back a bit. 3, it's just, I guess, wonky controls. A little bit. Moving the bias voltage, or the ABC and the bias voltage, what it really is, up and down a volt with the tone control. Boy, that just doesn't seem right. So how would that happen? Because I think from a DC point of view, you can see through here. You can see it. Yeah, all the way. There's no capacitor. Look, DC, 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 all the way to the ground. So that's what's going on. So oddly enough, they built this in such a way, even though there's a pile of resistors involved, fooling around with this tone control, I think accidentally moves the bias voltage up and down. I don't think that's an intentional thing. Yeah, maybe it is. Now, why would they want to do that? Because as you knock, if you want to bring the bass up in a radio, you can knock down the treble and then raise the volume. And presto, you'll think the bass has been turned up. But really, you just knock down the treble, rolls off the treble, and then raise the whole thing. Maybe that's what's going on here. Now, that makes sense. Oh boy, this is a little tricky to analyze. So if this control is all the way to the bottom, we are bleeding out the least amount of treble. So with this on the bottom, the bass should be boosted. With this on the bottom, you have reduced the resistance pulling on all this. So this would allow this to float higher, be more negative, quieter. Okay, so we got quieter when we're calling for bass. That's exactly the opposite of what I just said. That's right, that's exactly the opposite of what I just said. So it's even quieter. So I don't know what's in the heads of the people who make these radios. Okay. I'm just waiting for a really good idea to pop out here. Well, I've spent quite a bit of time here poking around, and right now the meter is hooked up across a 10 megohm resistor, and you can see the reading is 3 megohms. 10 megohm resistor is this guy here. studied this diagram, fooled around with the radio to try to convince myself that the 3 megohms is a false reading, and it really is a 10 megohm resistor in parallel with something else that's giving this 3 megohm reading. I'm hesitant to jump in there and cut that resistor out because it's in a very awkward location, so I'm trying to convince myself so I don't waste time and take risk unnecessarily. But at this point, the only conclusion I can reach is this 10 megohm resistor is actually 3, which is really odd. And I just can't see studying this any further is going to change that opinion or that situation. So I got to go in, I got to cut. I'm going to cut one leg open on this resistor and then unfortunately discover it's actually 10 megohms. That's what's going to happen here. Actually, you know what? There's enough here. I can probably cut it and reattach it down here if I really want to. Can I pull it off? It's going to be a factory-made connection, so you can't just pull it off. You have to cut it away. Let's cut it away and find out what happens. Cut. Pull off the wire cover. Oh man, here we go. I'm sure this is going to say 10. The situation could be worse. There we go. 10, 12, 13. Okay. Isn't that kind of wonky, didn't it? What's all that? Jumping around like that. Probably my clip leads. Got it out. I have trouble with these clip leads all the time. Let's go back to the regular leads. Even though I've taken the time to solder all my clip leads, I still don't trust them. See how this works out. Okay, so one end is one end is there, the other end is here. Why is it jumping around like that, though? You're coming out for a closer look. You're done, buddy. You didn't pass the test. Sorry, you've reached the age of retirement. Retirement for a resistor is not a happy time. Just get the resistor and nothing else. I haven't done the resoldering. When I went to do the resoldering of the socket connections, I discovered this resistor and got curious about it. It's hidden from view. I think I've just gone down a happy trail here for no good reason. Let's see. Why is it behaving like that? It's like charging up. So I think this resistor is wonky. I don't know what to make of it here. It's I guess if you have a component and its values are changing kind of randomly, that would really make it difficult. So there's a term applied to radios that seem impossible to repair, and the term is a dog. It's called a dog. It's an old... Why was it 0 there at first? Or open? It's pretty convincing it's 13. Not what I thought. I thought it was low. Okay. So if it's supposed to be 10 megohms, but it's 13 megohms, I can't see that that's going to cause a big problem. But and we'll put in the proper size resistor. We'll see what happens. Okay, ready or not, here we go. So I've replaced the resistor in there. I did resolder a couple of connections that I had soldered myself earlier, but I left the originals just as they are. They look great. They look perfectly fine. Okay, when you're getting down to the point where you're looking for cold solder joints, then wow, you're reaching the end of the list. So let's hope this works now. Did I turn the radio on? No, let's turn the radio on. Everything's fine. Any smoke from that resistor? I don't expect so. Now, what are the chances that changing that resistor fixes this radio? Wow, you know what? I wouldn't bet a dime on that. Wow, good thing I kept my money in my pocket. Seems a little different. Oh. That's interesting. I got it up full now. It is a little different. Hang on to your ears. It's going to break into oscillation here at some point. That's a pretty good prediction, eh? I don't know what happened there. It just suddenly went. Why? It's right on the verge. Lots more poking around here, and back to this. Solder time. Okay, so I've resoldered both ends of this noisy capacitor that I put in, you know, that could be the whole problem right there. It's, for some reason this capacitor was not connected to ground properly, then everything that's been going on could be going on. Let's find out before I say too much, if I already said too much. That was it. That was it. That's it. That's all it was. You know, stupid me. Radio's working. Put 2 capacitors in. Radio stopped working. You'd think I'd be suspicious of those 2 capacitors. I examine them very carefully. Everything looks fine, but looks can be deceiving. Okay, all that crazy nonsense is over. Really? Is it really? Yes, it is. So let's give this guy a chance now. A chance on an antenna. Chance on an outdoor antenna. Okay, radio, make me proud, even though I'm totally embarrassed about how long it took to find my own mistake. You know, it's true. Okay, man, play me some radio. Station's down here.
Boss, mistreatment, harassment, discrimination, being let go, laid off, whatever it is, reach out to me and call. And to get us revved up here on the show, John, let's talk about a couple of situations that came across my desk very recently.
That's it.
I spoke with a lady who was let go from her job. Now, she had made a mistake with a client.
So I kind of feel I have to do a bit of an epilogue here on this kind of problem. Problem generated by me and the work I'm doing, which then sends me off in every direction under the sun, looking for a problem that's hidden in the work I already did. I even tapped that capacitor early on and discovered the pop, and then I got distracted somehow and never went back to it. So here's the thing, when you're doing this kind of work and you're working away on a radio, there's always a new radio, things are different. There's a process of discovering lots of stuff about the radio. So the fact that I spent a lot of time rummaging around all over the place, changing a few parts and doing other stuff, only helped me get more and more in tune with the radio. And since I'm scratching my head and thinking hard to try to find the problem, which I should have found very quickly, this just forces me in my head all through the radio. This is a good thing for anybody doing this kind of work. It's actually, you know, when you finally find a problem and you go, oh my God, I should have found that a long time ago. It was my own fault. It should never have happened. Look at all the time I wasted. That's where you need to stop and say, hey, I found some interesting things while I was wandering around in the dark. So that's my statement on that. But now I think the radio is really, really ready to go. I think it is. Just as an example, by the way, I probably would have left the original tube in here. It'd be interesting to put it back in there and see what kind of effects an unshielded tube has on this radio. But for now I'm on to other things. Thanks so much for watching, and it's alignment and finish up from here, I think.